Good morning, students. In our last class, we complete up to question number 5. I hope all of you understood all these 5 questions. So today, we discuss the question number 6 as well as the question number 7. So now here, if you see the question number 6, the question is given like in this way. Find the maximum profit that a company can make, comma, if the profit function is given by px equals to 41 minus 72x minus 18x square. So now here in this question, what you have to do? Maximum profit we have to find out. That means here we have to find out the maximum value. As you see, the given function is given px equal to 41 minus 72x minus 18x square. Is it clear? So now this one is an algebraic function, so that's why here if we apply the second derivative method, so easily we can find out the maximum value. So let's start now. As you see here, the profit function is given by, the function is given px equal to 41 minus 72x minus 18x square. So all of we know, in case of maximum and minimum, what we have to do? First of all, we have to differentiate the result with respect to x. So that's why p dash of x equal to ddx of constant term 0, ddx of minus 72x means minus 72, and here we get minus 18 into x square. If we differentiate, then twice x, ultimately minus 36x. So p dash of x equals to minus 72 minus 36x. So now according to our rule, we have to write p dash of x equal to 0, and when we write p dash of x equals to 0, in place of p dash of x we write this result, and if we write this result, then here we write minus 72 minus 36x equals to 0. So now here, from if we find out the value of x after calculating this one, so the value of x is, here we get minus 2, if you see here. So which one is known as here critical points. Is it clear? So we don't know at this point we get a maximum value or minimum value. For that reason we have to verify this one first of all, and then after that we have to find out the maximum profit. Is it clear? Okay. If we differentiate again, here we get p double dash of x. Since the function is p dash of x equal to minus 72 minus 36x, so if you differentiate this one, minus 72 now constant term, so simply remain here minus 36. So that's why here we write p double dash of x equals to minus 36. Now in place of x we have to put the critical point to verify this result. So when x equal to minus 2, if we put here, then there is no x, simply here remain minus 36, and which one is a negative value, so that means less than 0. So according to our second derivative method, we know if less than 0 we get maxima, and if greater than 0 we get minima. So here negative value, so that means less than 0, so that's why we get maxima. So that's why here written, so px has maximum profit at x equal to minus 2. Is it clear? So now here we have to find out the maximum profit. So therefore maximum profit, so where we have to put this critical point? On the given function. So if you see the function is here px equal to 41 minus 72x minus 18x square. So if we put minus 2 here, then 41 minus this one we write, and after calculating this one, finally we get the answer is how much? Answer we get here 113. Is it clear? So in question number 6, the maximum profit is how much? 113. Is it clear? Okay. After completing the question number 6, if you see the next one, question number 7, and the question is given in this way: find both the maximum value and the minimum value of the given function is here 3x to the power 4 minus 8x cube plus 12x square minus 48x plus 25 on the interval 0, 3 and close interval given. So one thing we know, in case of close interval, always we have to apply the absolute maxima and absolute minima method, which one is also known as first derivative method, is not it? So if we apply this one, it is very easily we can find out the maximum and minimum value. So what is absolute maxima and absolute minima? So first of all, from the given function we have to find out the critical point, and these critical points are always lies between the given interval. And after that, taking the critical point including the end point of the interval, the maximum value is known as maximum and the lowest value is known as the minimum one. Is it clear? Okay, now let's see here the solution. If you see, the solution is given like in this way: fx equals to, here in this case, 3x to the power 4 minus 8x cube plus 12x square minus 48x plus 25. If we differentiate this one with respect to x, ddx of fx means f dash of x, and when we differentiate 3x to the power 4, then we get 12x cube, 8x cube. If we differentiate 24x square, then 24x minus 48. Is it clear? If we differentiate this one, then we get this one. And now here, according to our law, f dash of x equal to 0 we have to write, and then in place of f dash of x, this result we have to put here. And after that, from here we have to find out the critical point. So when we have to find out the critical point, first taking 12 common, and then after that, if you see here, x cube minus 2x square plus 2x minus 4 equal to 0. So in first case, x square is common, so x square, if you take common, x minus 2 remain, plus in these two cases, if 2 common, then here remain x minus 2 equal to 0. And from here finally we get x minus 2 into x square plus 2. Is it clear? Okay, now after that, if you see here, when we find out the critical points here, either x minus 2 equal to 0 or x square plus 2 equal to 0. So from here x equal to 2 we get, but in this case it is not possible. Why? Because x square plus 2 equal to 0 gives us an imaginary value. Is it clear? Okay, now after finding the critical points and including the end point means here, if you see, the end points are 0 and 3. So that's why here written, we shall now evaluate the value of f at x equal to 2. That means the critical point, and at the end points of the interval 0, 3. So that means here we have to take this points. So that means this one is x equal to 0, x equal to 2 and x equal to 3. Is it clear? These values are we have to take. And now here one by one we have to find out the value. For this, first of all we have to consider the function. Again, fx equal to, this one is the function here, and in this function we put x equal to 0. So when we put x equal to 0, this result is 0, 0, 0, 0. Ultimately what will remain? 25 remain. Is it clear? So next point is here we have to put 2. So when we put 2, after calculating this one, that means in place of x we have to put 2, and each and every places we have to put 2, and after calculating this one we get minus 39. Is it clear? And then finally the last one is, here we have to put 3, and then when we put 3 here in place of x, that means here in place of x if we put 3, and after calculating this result we get 16. So now here among all these 3, the maximum one is obviously 25. 25 minus 39 and 16, so 25 is the maximum one. So that's why here the maximum value is 25. And which one is the minimum one? So obviously minus 39. So that means the minimum value is minus 39. Is it clear? I hope all of you understood these two questions. So in our next class we have to continue this exercise, and another very important 3 or 4 questions are remain there. isn't it? So you have to copy these two questions properly. So in our next class we have to continue this exercise. Okay, thank you.